Hello and welcome to Keep Coding. I'm sorry that I'm doing a video after a very long time in this series, but I'll try to do more videos going forward. In this video, we're going to see how we're going to create a singly linked list using Go. Of course, we'll be using generics. Now, let me create a package and I want to name it list. And within this, I'm going to create a new file named single list.go. Okay. Package name will be list. Okay, and as usual we'll be creating a type, and this type will be similar to what we created in Q. It will be an item of the same structure. Okay, the reason is we used linked list to create queue and stack as well. The technique that we used was using singly linked list, but what we're going to do now is that we're going to create a list with more operations, which means that we'll be creating operations like insert and modify, where you'll be able to insert an item in between the list, maybe at the middle, at the beginning, or at the end. Okay, and now we need one more type named list of type any, and this will be a struct as well, and this is going to have only a head. Okay, so this list will be having a single pointer which will be pointing to the first item of the linked list, and the subsequent items will be pointed by the item prior to that, which means that the first item will have a pointer to the second item and the second item will have a pointer to the third item. Okay, so now this is going to be like just this is the only reference that this structure is going to have. Okay, and now we're going to add operations to it. The first operation that I want to add is like append, which is similar to enqueue or push in the other data structures that we saw. Okay, but here I'm calling it as append because it is a list, so I'm going to call it append. Okay, so I'm naming it append. It will take a value, it will always add, so I don't have to give a return type to say whether it has added successfully or not. Okay, so now I have to see if the list is empty or not. For that I have to check if head, sorry, I have to use l.head, my bad, actually it is a function, yeah, equals nil, then that means that this list is not having any item, and we're gonna create a new item, which means I'll have new item equals, I'm gonna create an item here with the value t and nil. Okay, so this, since we are using generics, we are supposed to pass the type, so I'm giving the same type as t. Okay, so now I create a new item, and now this l.head is supposed to point to new item. Okay, and obviously when I'm creating, I'm creating the next as nil, so that this item is not going to have any item after this, because this is the first item that we are adding to the list, right? And so I'm not going to fill anything after this. What if the list is not empty, it is having items already? Then in that case what I'm going to do is that I'm going to have a pointer to the head. Okay, so I'm just creating a cursor which will be pointing to the head now, and then what it will do is that while ptr.next is not equal to nil, it will further travel. Okay, means ptr equals ptr.next. If you're having say 10 items, it will say, it will go through all the items and it will stop pointing at the 10th item, which will have only nil after that. Okay, so where it is stopping, there I have to add the new item. Okay, I have to put an address operator here. So this is how we are adding an item at the end, and this is how we are adding an item at the beginning. Okay, and in both the cases we are not going to have any other item after the item that we are adding, because we are doing append, which means we are adding the item at the end of the list. Okay, so you don't have to worry about handling the new item dot next, which means we'll be always having that as nil. Okay, because no other item is following this item. Now we are supposed to test this, and I'm going to main.go. I'm going to say create a new list dot list, and this list will not be having anything at the beginning. So now I'll say okay, so it has started importing this, but this is not what I wanted to be imported. Okay, I just wanted to import from this. Okay, here yeah, we are supposed to pass a generic type, so I'm passing an int. Okay, so I can add any integers, say 10, and now I need a way to verify that these items are added. I need a way to get it and print it on the screen. So for that I'm going to add one more method, which is going to say ForEach, which means this method will take a callback function, and it will execute the function with each value in the list. Okay, so I'll need the same logic. Okay, so and then for each of these pointer, instead of ptr at next, I'm going to say ptr, and I'm going to do the callback, and I'll be passing the value, which is ptr.value. Okay, so what it simply does is that I'm looping through all the items from head till the last item, and for each item I'll be calling the callback with the value that is stored in that item. Okay, so this is supposed to help us like this. I'm going to say for each, and I'm going to introduce a function value of type int, and here I'm going to say that fmt dot println, I'm printing the value. Now let's try running this. We should see at 10. It is printing 10 forever, which means something is wrong. I made something wrong here. So if you see, if the list is empty, I have to add it, and I have to quit immediately at this point. Okay, because I don't have to continue on doing this. If the list is not empty, then I'll continue and assign the new item, and then I'll just exit. Okay, so now let's try. See, it is printing only once. So now the append operation is working fine, and we have implemented for each as well. Now what if I wanted to get an item at a particular index? Say if I added two more stuffs, say 20 and 30. Okay, so now I'm running it again. I'm seeing 10, 20, 30. Okay, so what if I want to get a particular item at a particular index and then print it on screen? So in that case I need to have a method named get. Okay, so So it should be similar to this, but it will be get, and it will take an index of type int, and it is supposed to return a value of type t and OK of type boolean. Okay, the reason that I'm having is that, say you are having a list which is having only 5 items, and then you are giving an index of 10, which means that it cannot return you any item, right? So in that case, this is supposed to return a false, so that you know that this value that you are reading from here is useless. Okay, so what I'll do is that, so initially I'll check that if the list is empty. If the list is empty, obviously I don't have an item at that index, so I can return a false immediately. Okay, so in that case I need one more method. I'm gonna call it is empty, and then this one will not take any parameter, and this will return only a boolean. Okay, so here I'm going to say if l.head equals nil, that means this is empty. Okay, return true, otherwise return false. Okay, so that I can easily check in multiple methods that if L is empty, then I can return val comma false, which means this is not having any item at that particular index. Now otherwise I'm going to have a pointer, and this pointer is supposed to point to head, and then since we are dealing with index, I need a counter to start counting. Okay, so I'm gonna have a cursor value of 0, and I'm gonna increment this cursor till the cursor is actually less than index. Till that I'll be incrementing this. Okay, what I'm gonna do is that cursor plus plus, and at the same time I'll be saying ptr equals ptr dot next. Okay, so I shouldn't be using this. Yeah, so at the same time if that index is beyond the length of the list, then this ptr equals ptr dot next cannot work forever, right? So at some point this will fail. So in that case I'm gonna say this has to be true, but also ptr cannot be null, otherwise ptr dot next is not possible, it will throw an error. Okay, ptr cannot be null, and once this loop is executed, you will end up at the exact point that you wanted to come to. Say if you're having 10 items and you're giving an index of 5, then this loop will execute till 5, which means this pointer will be pointing to the 5th item. At this point you'll be able to return the item, but before that, if the loop has exited because of the pointer being nil, which means the index is beyond the length of the list, then in that case I need to make sure that if ptr is nil, then I don't have a value. I need to return a false. Okay, otherwise I have a value. In that case I'll be returning ptr.val and then a false. Okay, yeah, now we're going to test this. Now I have 3 items, and I don't want to print every item. Instead I want to print the item at position 1, which means 20. This is at 0, this is at 1, and this is at 2. Okay, so I'm gonna say val comma okay equals list dot get and I'm gonna say that index 1, if okay, then I'm gonna say that fmt.println value, otherwise print fmt println not found. Okay, so now let me run this. Not found. Okay, so it is not working as expected. It is supposed to print 20, but it is printing not found. Let's find the issue. The reason is I have to return a true here, but I'm returning a false. Now let's try again. See, it is printing 20, and if I give 3, it should be returning not found because there is only item till 2, 0, 1 and 2. Okay, it is working as expected. Okay, so now we are able to get an item at a particular index. Okay, now if we are able to get an item at a particular index, we should be able to modify the item at that particular index as well. So I'm just going to create an entire copy of this. I'm going to say modify, and modify is supposed to take a value of type t, and it is not going to return anything, but it will just return a boolean. It is not going to return a value, but only a boolean. If the modification is successful, it will return a true, otherwise it will return a false. So if the list is empty, we are going to return a false, otherwise we'll be going through the list, incrementing and finding that position. And if the list is shorter than the index, then we'll be returning a false, obviously. Otherwise we will say that ptr.val equals the new val that we have passed here, and that's how we have modified it. And now I'm going to return a true. Okay, now let's test this. Now I'm going to say that I have 3 items. I'm going to modify the item at position 1 with 15. Okay, so but I'll be having only 1. Okay, I don't need this actually. Instead, what I'm going to do is that I'm going to just print the entire list so that you can see that which item has changed. Okay, so now I don't need this. Okay, now I'm modifying this and then printing the entire list. See, 20 has become 15 because I have modified it. What if I'm trying to modify something that is not existent? So at item 6, it will not crash. But it will not have any updated list. It will still have the old value. Okay, so that's how modify is also working. So now we have next the most complex of them all, which is insert and delete. The reason that I'm saying this is complex is that you are supposed to deal with the links of the list. When you are inserting a new item, you will be breaking that existing link and adding a new item between it, so that the previous item will point to the new item and the new item will point to the previously old item which was there at that place. Okay, so now that is what we are going to do. And let me create a function for insert. So I'll just copy this, and inserting can succeed or fail as well, because you'll be creating giving an index, and that index can be out of bounds. Okay, so I'm going to say insert, you'll get a value and you'll have an index so that you can insert it. Now when you are going to insert a new item, you are supposed to create a new item. So similar to append, you'll be having a new item, and the item will be having this value, and it will be taking the nil as well. Okay, now if L is empty, then what I have to do is that I need to see if the index is 0. Okay, if the index is 0, then I can easily add it. If index equals 0, then I'll just append the new item that you're given to the list, which means L dot append new item. Okay, sorry, I don't have to give the new item. I will be giving just the value, because the new item will be created automatically by that append. So I can just throw this away. Okay, another case is the list can just be empty, but the index that you are given is something like 10. In that case, obviously you cannot insert an item at 10 to an empty list, right? So in that case, we'll be returning a false. Okay, after appending, we'll return here so that we don't continue on any other logic. And then you can have a case like the list is not empty, but then the index is 0, which means you have to add an item at the beginning. Okay, so to check that, I'm going to say else if index equals 0. Okay, and here I'm going to say that I am going to have a temporary variable to hold what is there at the head now. Okay, now we are going to replace the head, because we are going to add an item at the topmost level, right? So I need to replace the head, so I'm keeping the head somewhere else in a temp, and then the new item will be placed into the head. Okay, so now new item is going to head, and then new items next will be pointing to the previous head, which is something that we're keeping at temp. Okay, now what is wrong here? Yeah, I cannot have this assignment. Okay, so it is kind of a swapping that happens, and then we have the new item at the topmost level. Okay, so now after this, I get return. Now this is a very good case for a switch statement in Go. So I can put a switch here, and then put all these in this, and I can say case, this is the case, do this, and then if this is the case, then just return a false. We have a third case. Here I have to return a true and return a true. Okay, and we'll have a fourth case, which is the default case, which will be all the other possible cases, which is like you place an item on an existing list in the middle, or at the end, or at any places. Okay, so for this we'll need the pointer, and this pointer we need has to point to pointer dot head, L dot head, and now we need to loop through all the items just like how we did earlier, but this time we'll try to stop. We need a cursor because we are having an index, so we'll have a cursor, and then we'll keep incrementing till we find the right place to insert the item. And this time I'll just do a -1, so that I have to stop one item before, so that I'll be able to update the link of that item to point to the next item. Okay, so in previous cases when we are getting, we exactly stopped at the index so that we return the value or modify the value. But to insert the value, we have to stop at one node before, one item before, so that I can update the link for the next item. Okay. Yes. So now after this, as usual, I need to check if ptr is nil, so that I can make sure that this item, the index is not beyond the length of the list. So in that case, I have to return a false. Okay. Otherwise, I just need to do the swapping again. Okay. This time I need a temp, and this temp will point to the item, the current next item, and that has to be updated with new item. The new items next will be updated with temp. Okay. After doing all this, you have successfully updated or inserted into the list, so you'll be returning a true. Okay, so that's it. Now we have returned the insert. All we have to do is test if this one is working as expected. Okay, so now we have 3 items. I'm gonna say that list dot insert an item at position 1, which means it has to be inserted above 20. I'm gonna insert 15 above 20. Okay, so I'm just removing this modify as well. So let me just totally remove all this. Okay, now let me run it. See, now an item has been added at 50. If I give 0, then it has to be added at the beginning of the list. Yes, it is doing it. If I give 2, it has to add just about 30. Okay, so now it is inserting as expected. For any other case, for any other value, like say if I'm giving 5, it will not break, but it will not add anything to the list because it will return a boolean of false. So that works as expected. Okay, so now we have only delete. Let me copy this for delete and naming it as delete. So it is not going to take any value, but it will be taking index. Okay, and then we'll be obviously returning a boolean specifying whether we deleted an item or not. So now delete is also having all these cases. So what I'm going to do is I'm just going to copy everything from insert, and I'm not going to create any new item. In the case of empty, I'm going to return a false because I didn't delete any item. So I just need, I don't need this case because we have index equal to 0 already here. So in this case, we know that at this point the list is not empty. So all I have to do is L dot head equals L dot head dot next. Okay, which means we have skipped the first item and we are pointing to the next items automatically. The first item will be deleted. Okay, so in the other case we need a cursor, obviously, since we are having index, and we need a pointer, and I need one more pointer here which is going to say previous. So I have to define that here, pre pointer, and this is going to be a pointer for item of type T. I have to use this whenever ptr becomes ptr next. Before that, prev ptr equals ptr. So I always am tracking two pointers. One is for the previous item and the other is for the actual pointer, whichever item that I'm going to delete. I'm removing -1 here because I want pointer to point to the item exactly which I'm going to delete. So I have removed -1 there. And here if ptr equals nil, then we're going to return false. And then finally, while deleting, it becomes like this. So prev pointer dot next should be equal to ptr dot next. Okay, so that the item that is currently pointed by ptr just vanishes from the link. Okay, in this case we'll be returning a true. Let's see if this is working. So I have inserted one item, so we'll have 4 items. Now I'm gonna delete. Let me just remove insert, so it's not complicated. List dot delete, and I have to give an index, and the index is going to be 1. I'm trying to delete 20 now. Okay, now let's run this. See, 20 is deleted. What if I give 0? Yes, 10 is out. What if I give 2? 30 is out. But what if I give 3? It shouldn't delete anything. It should just return a false, which we are not actually checking. So see, it is returning all the values. Okay, so that's it. So we have implemented all these functionalities: append, delete, ForEach, get, insert, and isEmpty, and then modify to a linked list. So this is a very good list to use in for any case, because we are having generics as well. Let me know your feedback about this, or if you have any better logic to do it, and please subscribe for more videos related to data structures. Thank you.